So here I'll do a quick walkthrough of two sub-assemblies I made for the purposes of more efficiently designing municipal roadway projects in Civil 3D. The intent was, one, to be able to minimize drafting on cross sections, manual drafting, so that we can get the assemblies to appear exactly how we want them to be in the finished product, something that we couldn't successfully do with the assemblies that Civil 3D provides out of the box. The other thing, in addition to the drafting issues, is the quantity takeoff. So in order to take full advantage of the QTO tools and the volume report tools to take off roadway select materials, driveway materials, as well as cuts and fills, we had to make these custom assemblies in such a way that they were coded to create the surfaces we wanted and to identify the shapes of these different materials that we want for our takeoff. So here on the left I have a sample section of a corridor that I've designed, or that we're working on here, that has the sidewalk and grass strip adjacent to a driveway. There's actually driveways on both sides here. So let me first show you the roadway assembly at the curb line that I've created. This assembly here is called lane and shoulder curved. It's used as the last assembly that takes you to the gutter line, and it's designed to have a curb, granite curb here, as you can see, and any adjacent sub-assembly, whether it be a sidewalk like you see up here, or it could be just loam and seed or any other kind of daylight assembly. The problem with the out of the box setup is that you can't get this material to wrap under and behind the curb and create this line that you see here, which in this case stops at the bottom of the sidewalk. So what I did in the parameters of this subassembly is I created a variable that allows you to modify this distance here. So if this subassembly is used in the case of a sidewalk, then this length value of 1.5 will stop that vertical line right here, and that would be all of this orange material that would wrap under the sidewalk. The distance used here, the one visible in this actual sidewalk assembly, was 0.796. So this was 0.796. This right here on this subassembly would accommodate this sidewalk, as you can see. So the sidewalk assembly would be attached here. Now in a case where you've got a driveway, and we've got that shown here, so you're seeing up above here, you're seeing this cross section at this sample line, where we've got on the left, we've got a sidewalk and grass strip. When I'm making a subassembly, an assembly for the purposes of using a driveway, I can take this same subassembly, and you can see here a toggle for curb, yes or no. So I can shut off the curb, which terminates that there, and that brings in my, then allows me to attach my driveway assembly. So here's the driveway subassembly, which I can add to this and move to here. Now the driveway subassembly also does a number of things that's really cool and makes the urban design process a lot more efficient. Our standard driveways for New Hampshire DOT, they typically have a lip here, a couple inches, 2-inch lip, over 6 inches. That's over the same footprint that the adjacent curb would be. And then you've got this this panel, the shelf. This basically matches the slope of the sidewalk. And then you've got this remaining portion here, which is what daylights to existing ground. Now our design criteria Our design standard requires that we maintain a maximum slope delta of 10% between the shelf slope and the daylight slope. So if the driveway is in a fill, then this would be 8.4%, as you see in this section. As you see in this example here. If the driveway were in a cut section, then the slope would be 11.6%. As you can see, the difference in both, depending on the direction of the daylight, is a delta max of 10% over this, which is 1.6%, matching the sidewalk. Now, the way I've designed this subassembly is that delta of 10% is a default, but it is adjustable. So you can see here max slope delta of 10%. If you said, well, we're going to allow a max delta of 12%, then your corresponding corridor daylighting will affect that difference. So what happens is you have the ability to apply this subassembly using the max delta that you use as your criteria. And then, as you begin to look at the results of the corridor, you can make a determination in some spots that you may want to override the calculated slope. So let me move this. Let's take a look at a section at the driveway. Driveways on both sides here. So just inside, you have a driveway, 8.4%, and on the right, it's a cut, 11.6%. So when you're looking at your individual sections, because of the way I designed this driveway subassembly, you can override the calculated slope. So the calculated slope here, right now it's not being overridden, but you can override the calculated slope and set your own slope, in which case that override will be applied. Another option is you look at your design with the max delta slope applied, and you look in a driveway by driveway case basis, like this one for example, and say, well, it actually makes sense that we bring the driveway limit up to here. So all you have to do is change the way the driveway daylights, the way it terminates. I've designed this segment here by default in your original pass to use the surface and the max delta to daylight, but you can change that here. You can change the target type from surface to entities. So I've done this first pass. I look at this daylight point here and I say, well, I'd like this driveway to be squared off up here. So I can actually change the assembly now once I've gone through this first iteration of the design. I can change it, change the entire assembly, as I'm doing here by changing this property, or I could do it on a section by section basis using the corridor section editor. But for simplicity, I'll just do it right here. I'll change it to entities. So the target type for this is entities as opposed to surface. So then I could go into my corridor properties for a given region, modify the targets. I'll do this region here. This one I'll just leave as it is for now. You'll see the difference in this region. I select my corridor target for my driveway on the left, daylight offset target. I'll select from the drawing the entities, and I have a polyline here for that purpose. Click OK. Rebuild the corridor. Now you'll see the driveway will no longer be daylighting based on that max delta slope to some surface. Instead, it will go to that target entity and the slope will vary. In this case, obviously, it will be flatter than the slope we got at first. And there you have it. Ends up being 3.2% when it's stretched out to this point. So in summary, got this great subassembly, these two subassemblies, one that can be curbed and used in an assembly for the areas just in advance and after the driveways, and then that same gutter line assembly you can shut the curb off and in this case be used as part of a driveway assembly. And again, the idea is that you're able to get the proper materials to show for quantification purposes and for drafting purposes the way we want them to show. So there's no manual drafting, there's no shutting off assemblies or corridors and drawing things manually to get them to look the way you want. And then you also have the ability, after seeing what your preliminary pass does, you have the ability to set some targets here and override and get clean, square driveways, daylighting where, in the end, you, the engineer, wants them to do.